welcome back to the MeshForge tutorial series. For this video, we're going to be discussing the gap filler tool. Before we get started, let's talk a little bit about the gap filler tool and what its use case is. So the easiest way to see this is to take the same prefab that we worked with in the splitter tutorial, drag and drop it into your scene. Once you have its position and rotation set to 0, 0 on all axes, we're going to go ahead and drop down the hierarchy, and we're going to go down into the parted meshes. All I need you to do is wherever your chest is located, go ahead and disable it. So as you can see, when I disabled the chest, you can actually see all of the open gaps in the mesh. Now this may not seem like a big deal. However, when you start putting together modular parts to characters that might be a slightly different size, or just slightly off in the section where you're actually trying to modularize, you're going to get gaps in the mesh. Another way to see this is here in the neck of the character. There's a big open space. You can see gaps here between the torso and the head and neck. And that's because we're working with two different assets. And these meshes were never meant to line up in the first place. But what the gap filler aims to do is to fill in that open space and hopefully allow it to look more natural. We're going to start by going to Tools, MeshForge, Gap Filler. Go ahead and dock that gap filler wherever you'd like. Let's go ahead and expand it so we can start talking about some of the fields that you'll be seeing. To start with, as always, there's the save folder at the top with our root folder name. And you can name that whatever you'd like. Next to it, you'll see that there is an overwrite saved objects field. And this is something that's really important that I'll have to go into more detail a little bit later in this video, but for right now, we're going to go ahead and turn it on. The next two fields, you have your handle draw distance. This is going to be the distance away that the vertices will be drawn. It's very similar to the splitter tool, wherein we have the distance check for the triangles being drawn to the scene. So next to it, we have the vertex handle size. It's exactly what you might think it is. It gives you the option to make the vertices larger or smaller. So how the gap filler works is we're going to simply click on a skin mesh and it's going to populate a preview in the scene. If you don't want your preview to be cluttered in with your actual prefab that you're working with, what I would do is I would move the camera position slightly away from the prefab so that way when it's actually instantiated into the scene, it won't be cluttered in with the prefab itself. We'll start by selecting the head, and here's the head skin mesh. So you'll see a few things change. There's a preview mesh object, as well as a new gap group is added. Let's go ahead and double click on the preview mesh object. So here you can see in action the handle draw distance and the vertex handle size. The handle draw distance, we can increase it or decrease it, and it'll change how far away we can actually start seeing these vertices before they disappear. To demonstrate the vertex handle size, all we got to do is increase or decrease the slider. So the first thing you want to do is get an idea of where you want to actually fill in. So this one's pretty self-explanatory. We know we need to fill in right here where the neck ends. There are two ways to do this. So the first thing you can do is you can start selecting from the outside and start selecting your vertices. If you do it this way, you're going to want to go in a clockwise rotation as you're selecting the vertices. And if you go inside the mesh and you do it from the inside, here, you're going to want to go in a counterclockwise rotation. To show what it might look like if you go in the wrong direction, I'll start clicking these in counterclockwise order from the outside. And as you can see, technically, these are going to be filling in. However, we won't see anything. And that's because everything is flipped in reverse, because we did it in the wrong order. So you can see here, this is where our new triangles were added and the faces were inverted. So now to get to the gap group, let's go ahead and start by going to the button that says Clear Group Selection and that'll clear our group and all the vertices we've selected so far. First, let's take a look at the fill mode. We have fan and we have convex. Fan fill is very simple. It'll create a flat surface, and that will be the surface that your triangles are filled in at. So here you can see you actually have a group color. The group color is meant to show when a vertice is selected. You can change it to any color you want, so you know what group you're actually working with when a vertice is selected. You have an option for a secondary material here. The secondary material is what's going to be filled in. Now, if you leave this blank, it's going to fill in with the original material from the mesh. So for demonstration, I'll show you here as I start to select in a clockwise fashion. And as those are getting filled in, it's using the original material and it's doing its best to keep it as seamless as possible. We'll go ahead and click clear again. This time I'll show you with a secondary material. We'll pick any one we want. For the UV flip direction, this will actually flip the rotation of your material that you're adding. So that way it's in a rotation that you prefer. For me, I'll go ahead and rotate it 180 degrees. You got to watch out for any vertices that are behind others, as it will punch through the overlaying vertices and select the back one. An easy way to make sure that you are selecting the vertices that you want to, you can hover over for just a second on that vertices and it will change color. Now, as I select it, you can see here that the material is added and it has added that 180 degree rotation. If we go back to none and then click update preview, we can see that this was actually its original rotation. And you can play around with it to get exactly what you want with the material rotation. All you have to do is change the rotation and update the preview. There you go. Let's go ahead and clear the group selection again. Now this time we're going to switch it over to convex fill. The aim for convex mode is for it to create the mesh in more of a cone shape. So there are going to be a few additional options to what fan fill has. So for convex steps, that describes how many loops we're going to be creating between the vertices that we actually select and the end of the mesh. So before we move into the convex exponent and the apex offset, the easiest way to show convex is to actually start building it out. So I'll start by selecting vertices that I want to fill in. And you can already see that it does look different than the fan fill mode. But what is actually different? Well, for starters, our convex steps are here represented as the loops between each vertices. So here's one loop set, here's our second loop set, and here's our third one. Now from there, we're going to be reaching our apex, and that's the center. If this was more protruded out, you would see that these surrounding vertices actually create a flat plane, and this represents the centroid of that flat plane. Let's go ahead and push out that apex offset. Now when I click update, you'll see that this actually protrudes inwards. Now every mesh is going to be different whether it protrudes inwards or outwards. So in this case, we're going to actually need to make this a negative number. Go ahead and click update again. There we go. So as you can see, it does protrude outward, and then we end up with this flat face at the very end with all of our convex steps in the middle. Now the next thing you can mess around with is the convex exponent. The simplest way to describe the convex exponent is that this represents a multiplier for how quickly we go from the starting vertices to the flat-faced or end vertices. It might be a bit counterintuitive at first, but as we raise this number higher, it's actually going to be much quicker to get to that endpoint. So it might even disregard the apex offset even though it's still a part of the calculations, it's going to apply some override because this is a multiplier. So when we press update preview again, you'll see that the mesh is actually a lot closer to the original vertices. And that's because we're not letting it extend out any further. It concludes much faster to that final vertices. And that's because of this convex exponent. And as you can see, as I lower it and then update again, it takes longer for that conclusion to happen. And so it's going to push it out further. And what happens if we start messing around with the apex offset from here? Let's say we push it out further. As you can see, it still does play a part in how the mesh is going to be created. And so it's best to play with all of these settings. Remember, they are very sensitive. And also remember the apex offset needs to go in either direction for this to work. So I'll go ahead and reset this down to negative 0.25 and then update preview. As for the convex exponent, I'll set it to 10. So we still have a bit of protrusion, but it doesn't go out as far. And again, as I get closer, you'll see that it collapses in on itself at a much earlier time. You may notice that your convex steps don't look like they're there anymore. However, if you zoom in here, you can see it's just actually concluding very rapidly to the next convex step. But it is actually still present. So the next thing we want to do, again, when making sure that our overwrite saved objects is selected as true, we want to finalize. Now, overriding saved objects should be pretty self-explanatory. It is going to override our previous object. However, if I was to leave, we would start getting and collecting a lot of meshes inside of our folders that we won't necessarily want to keep, and we might forget to actually delete them later on. So it's best to keep this active unless you know you want to create a variant of that mesh. Now, another interesting thing we can do with gap filler is we can actually reselect the head that we already filled, and we can start working on that again. I can select back in convex. I can set this back to 3. I can move this back up to 10, change this back to negative 0.25, change the material now to a new one. We'll just go with one random one. Rotate it a different rotation, and start selecting our vertices on the boundary. And as you can see, using the same settings, we're actually creating a stack here. And you can continue to do this as long as you keep finalizing and overwriting. You won't get a bunch of junk, and you'll get your mesh to be looking exactly how you want. The next thing I want to demonstrate is how to fill in gaps that are a little bit more complex. So for this demonstration, I'll click on where the legs are. As you can see here, we have a gap right here, a gap right here, and then this larger overall gap. And as you might imagine, we can't simply select all of the vertices on the top to fill in the top and then select these smaller squares here to fill in this. Because if they share vertices, they're going to change what that gap fill is going to look like. So you're going to have to take a multi-step approach to this, starting with, for me, I would start with the larger one and then fill in the smaller holes later. We'll keep it on a simple fan fill for this demonstration. Now, as we get closer to these other gaps, I'll go ahead and zoom in and show you that, yes, we will be selecting the vertices at the top of the gap. And that means that if I try to create a new group here and select one of these vertices, we'll actually lose that vertices to the new group. So the first thing we need to do is click Overwrite Saved Objects. Then we'll click Finalize. Once we do that, it'll add the filled in mesh to our prefab. And if you click on that prefab's new skinned mesh that's filled in, you can actually start working with that filled skin mesh. So the overwrite allows us to iterate this process out a little bit further. And now when I start filling in these gaps here, and adding a new group and filling in the second one, there are no issues between these two gaps and the original gap for the original filled mesh. Okay, now that all the gaps are filled, we can go ahead and finalize. And we can close the gap filler tool. Once we close the gap filler tool, we'll see that the preview disappears and our actually filled in mesh is going to be on our prefab. We can now get rid of our unfilled meshes if we'd like. I'm just going to go ahead and disable mine. And to make sure it does still work, here I have a controller and an avatar for this character. I'm going to click play and just make sure the animations look good and that there's no unnatural deformations. So just from a brief inspection, it looks like there are no abnormal deformations and it looks like the animations are doing just fine. So before we get going, I just want to show that we actually not only create meshes and skin meshes on our character prefab, but we are also creating static meshes. So if at any point you wanted to, for instance, have your character lose a limb, you can instantiate one of the static meshes and it'll be the equivalent to what you have in as a skin mesh. So that's all I have for today's tutorial. Thank you again, and I'll see you in the next one.